Dr. Charles Severance is one of the world's most popular programming instructors. In this course, he'll teach you C programming and object orientation with a little help from the classic C book from Kernighan and Ritchie. This is definitely the place to start if you want to learn C.
Welcome to C Programming for Everybody. My name is Charles Severance, and I'm your instructor for this course. This course and website is dedicated to learning the classic version of C programming language from the 1978 book, written by Brian W. Kernighan and Dennis M. Ritchie. This book places the reader in the middle of the 1970s transition from a hardware-centered computer science to a focus on writing portable and efficient software. C was used to develop operating systems like Unix, Minix, and Linux. Programming languages like Perl, Python, Java, and JavaScript and Ruby are all written in C. Software like early TCP/IP networking stack implementations that made the internet possible were written in C. And the first web browsers and web servers were written in C. Writing software in C enabled major advances in computer architecture and performance. Operating systems, compilers, and utilities could be recompiled to work on a new hardware platform once we had a C compiler for the new hardware. So much software has been written in C over the past 40 years that there's a very good chance much of the software that we use every day was either written in C or written in a programming language that was written in C. So we study C less as a programming language to use on a daily basis and more as the foundation of modern software and computing. In many ways, C is the technology equivalent of the Rosetta Stone in that it provides a connection between the programming languages of the past and the programming languages of the present. The name CC4E in www.cc4e.com refers to the original Unix command cc, which was the command that you used to compile your C program. CC stood for C compiler, and it is featured on the first page of the first chapter of the KNRC book. Programmers like me from the 1970s and 1980s typed CC on Unix systems like the AT&T 3B2 to compile and run their first Hello World program in C. This material is being presented under fair use as we are making use of material from a copyrighted work that is out of print and not broadly available in any format. The book is also not available in any accessible format. We are making use of this material in a teaching and research context with a focus on studying its contribution to computing history. The material is available for free and online to anyone who wants to learn about the history of the C language, computing, and computer architecture. Welcome to the course. Welcome to C Programming for Everybody. My name is Charles Severance, and I'm your instructor for this course. This course and website is dedicated to learning the classic version of C programming language from the 1978 book, written by Brian W. Kernighan and Dennis M. Ritchie. This book places the reader in the middle of the 1970s transition from a hardware-centered computer science to a focus on writing portable and efficient software. C was used to develop operating systems like Unix, Minix, and Linux. Programming languages like Perl, Python, Java, and JavaScript and Ruby are all written in C. Software like early TCP/IP networking stack implementations that made the internet possible were written in C. And the first web browsers and web servers were written in C. Writing software in C enabled major advances in computer architecture and performance. Operating systems, compilers, and utilities could be recompiled to work on a new hardware platform once we had a C compiler for the new hardware. So much software has been written in C over the past 40 years that there's a very good chance that much of the software that you use every day was either written in C or written in a programming language that was written in C. So we study C less as a programming language to use on a daily basis and more as the foundation of modern software and computing. In many ways, C is the technology equivalent of the Rosetta Stone in that it provides a connection between the programming languages of the past and the programming languages of the present. The name CC4E in www.cc4e.com refers to the original Unix command cc, which was the command that you used to compile your C program. CC stood for C compiler, and it is featured on the first page of the first chapter of the KNRC book. Programmers like me from the 1970s and 1980s typed CC on Unix systems like the AT&T 3B2 to compile and run their first Hello World program in C. This material is being presented under fair use as we are making use of material from a copyrighted work that is out of print and not broadly available in any format. The book is also not available in any accessible format. We are making use of this material in a teaching and research context with a focus on studying its contribution to computing history. The material is available for free and online to anyone who wants to learn about the history of the C language, computing, and computer architecture. Welcome to the course. Hello, and welcome to C Programming for Everybody. This lecture is putting C in a bit of a historical context. Now, if you're watching this lecture, you're probably familiar with some of my other classes. I just want to kind of let you know that I've been building a lot of classes. Most of you probably took Python for Everybody, available on Coursera, edX, and many other platforms. But I have a whole series of classes that are designed what I call the path of the master programmer, where I try to start people that no matter where you start, I want you to be able to learn to be a really good programmer and follow along as far as you want. These are all my materials. They're all 100% free, open, and online. And they're really aimed at teaching everybody how to program. I mean, I started doing this back in 2012 with Coursera, and I have dedicated myself to making all my materials free and to create a path that anyone can take anywhere in the world, regardless of economic challenges or other things in your life. I want everybody to have an opportunity to be a professional developer. So I encourage you, and frankly, if you haven't taken Python yet, like my Python for Everybody class, this course is going to be a little bit difficult. So let's start with a history of C. The book we're looking at, the Kernighan and Ritchie, C Programming Language by Brian W. Kernighan and Dennis M. Ritchie, was published in 1978. And the key thing is that it is a moment in history where everything changed. And so we're looking at this textbook and the text in this textbook and the language itself in the context of how it has impacted history. The C programming language itself has a long history. There was a language called B, and they were using it at AT&T Bell Labs to build utilities and operating system stuff, but it was a little too word-oriented. And so this language C was, as new computer hardware came out that supported byte addressing and the ability to load a string of bytes and store a string of bytes rather than a set of words, words being larger than a byte and more than one character were packed into words, and kind of like the 60s and early 70s. C wanted to make a character a sort of core, low-level kind of data that the language would happen. And from the early and mid 70s, the C and Unix kind of co-evolved. They wanted to build something that would make Unix work well on a PDP 1120, and at the same time make it so they could port Unix to other systems. But really, it was about the PDP 1120's cool memory architecture having to do with byte addressability. And what happened was they were carefully rewriting Unix in C, but then fixing C, laying the groundwork for Unix portability. And so by 1978, this KNR C book was published, and at that point you could think of it as a summary of over a decade of research in how to build a portable programming language, and then use that portable programming language to build a portable operating system, C and Unix, of course. By 1989, the C had become popular and there was a need to standardize it, so there's a variant of C called C89 that is the ANSI, and then that same version was called C90 as ISO, the International Organization of Standards, also standardized that. And so that was our first version of the C that we could all agree on. The ANSI did not intend to go too far away from what we call KNR C, but instead it just sort of nailed down a few things that by then were important to nail down. And C has continued to evolve from sort of 1990 to the present, and there's a number of major revisions, but the key thing that these revisions don't do in the modern version of C is they do not attempt to make C easy to use language, say like Python or JavaScript, and C knows its place in the panoply of languages and does a good job of that. So if we look at sort of what's the future, C is a difficult language to use as a general purpose language. Python is a great general purpose language, but it's not a great systems programming language. And the two things that are missing from C are the lack of really solid dynamic memory support in the core types and libraries. And then there is no safe string type. Strings are not, there's no string in C, it's character arrays, and arrays have sizes. And if you start putting stuff beyond the boundary of that array, things just blow up. And C++ is, to me, not the sort of future version of C. It's really a more powerful, intricate, and flexible version of C for programmers who are doing really professional, intricate systems applications. Writing good C++ in some ways is more difficult than writing good C. The languages that sort of take on in C's mantle in the general purpose are things like Java, JavaScript, C# or Python. The key thing with these languages is they don't give you sort of strings as just raw byte arrays. And they give us a simple object-oriented layer that keeps us away from the metal. The goal of C is to get close to the hardware, close to the metal. And so Java, JavaScript, C#, Python are all great languages, and they're great for what we use them for. They're just not well suited for writing an operating system kernel. The most likely language that is like C, like the next C, is probably Rust. The idea of Rust is that it stays close to the metal, but then gives us some simple and safe core data types. And recently, Linux is starting to accept some Rust in Linux. And so that means that Rust has to be mature. It means that Rust can't be like evolving rapidly. I've seen situations where operating systems like Mac OS decide to depend on Python. So there's parts of Mac OS that depend on Python 2. but then they can't really upgrade to Python 2 because of their operating system, blah, blah, blah. So for an operating system to depend on a programming language like Rust, it really has to be mature and, even more importantly, stable. You can't have clever innovations in the programming language causing regressions in an operating system, say like Linux. So I look for Rust. Now, C has been around a long time. Before C, we'll call C starting in 72, the book is published in 78. Before C, most of us would write assembly language or Fortran. Some people wrote PL1 that's not on here. Fortran is not really a general purpose programming language. You wouldn't write a command like cat in Fortran. Fortran was really for scientific computations, and the earliest of computers in the 50s, 60s were either sort of really specialized toward like payroll and HR systems, or they were really specialized to doing computations. And the ones that specialized were the science ones were used Fortran because it was just the right language for those computers that were aimed at doing scientific calculations. C as a language was kind of none of the above in that it was aimed at writing system code, a kernel, an operating system, and the utilities around it, including like other languages. And so C is kind of the mother tongue of all kinds of other derivative languages. And things like the Bash shell, Perl, Python, PHP, C++, JavaScript, Java, and C# and Objective-C just kind of were derivatives of this beginning of C. And that's why you see a lot of patterns in these other languages that are similar. And that's because JavaScript and Java both inherited their for loop syntax from C. So I've got a couple of videos in this section. This is Brian Kernighan and talking about the C programming language, and it's a short video. I didn't produce this video, but it's a great little video. Another video is from the creator of C++, Bjarne Stroustrup. This was an interview that I did with IEEE Computer Magazine. On top of this history of the C language, we can look at a brief history of computers. And I have a whole course called Internet History, Technology, and Security that really starts in the 1940s with a focus more on communication rather than computation, even though communication and computation were very much connected throughout the 40s through even today. In the early 1950s, computers were, you best think of them as like a multi-million-dollar strategic asset, every single computer, and a lot of them were custom built. The first computer at Michigan State University, where I went to undergrad, was built by the electrical engineering students of that university, based on some designs that they'd borrowed, I think, from Iowa. And so things like the programming language, the operating system, you didn't have a lot of generalization, you didn't have a lot of sharing. You tended to write code and put it on a paper tape or later a magnetic tape and load it and run it. And so you were just pretty happy if the code worked. You didn't need an operating system. These weren't multi-processing computers. And so the software environment was very minimalist. But in the late 50s and early 60s, you saw companies like IBM and Digital Equipment Corporation began selling general purpose computers. They just couldn't make them. And they started selling them. And they still were expensive, and they were only in, like, a business would have a couple of computers to help them do payroll, perhaps, or something like that. Something that was really, really important because the computers were expensive. But in the 60s, we really got to the point where the computer componentry, the chips, etc., were becoming commodities. You could just go to a place and buy chips, and then you could make a computer by buying a bunch of chips and putting those things together. And because you weren't building everything from scratch, the cost got a lot lower. The other thing that these less expensive computers were is they were a little slower. But by the end of the 1960s, there was a lot of computers. There were some, super expensive, weird, one-off, small production computers. There were computers that there was like the previous generation of mini computer where there were lots of them laying around old computer science departments. or businesses that weren't sure what they did with to do with them. They wanted to buy a new one. And then there were just innovative new low-cost computers coming out. And in the 70s, in this milieu of just lots of new and old computer hardware, the question was, is there a way we can do things with all of this old hardware? And is there sort of one solution? And that's where Unix and C came. And certainly after the 70s, we look at the 80s, and that's where microprocessors and personal computers. And so we went from computers that were sizes of refrigerators or desks to the size of a computer could be on a single chip. And in the beginning, those personal computers like the IBM PC or Commodore PET, they had really bad performance, but that performance, once you could get everything on a single chip, that performance could get faster very quickly. And because personal computers became a mass market item, a lot of money could be invested in personal computers. By the 1990s, personal computers continued to grow, right? And but the need to communicate and talk and exchange information became important. And so in the 1990s, we saw really an increasing focus on connecting computers with the internet and other kinds of networks. And the performance of these computers and the price kept going down, the performance kept going up. And then by the time we get to the 2000s, Amazon's AWS was founded in 2002, and it used personal computer microprocessors like from Intel and produced computing as a commodity, right? And so you don't even buy computers anymore. You just go to Amazon and say, I'll rent a computer for $7 a month. And so we see in 1978, we see this moment where we were going from the computers were becoming more common, they're going down in price, and there's getting to be more and more of them, and there was a diversity of computers. These days, there's actually less diversity. If we go back in history and you take a look at my Internet History class, you can see I go to Bletchley Park and show you some of the earliest computations from the 1940s and World War II. We go to Computer History Museum in California and visit with Gordon Bell and talk about the PDP-1, and he talks a lot about buying the components and putting the components together and how sort of the mass availability of relatively low-cost components really allowed for a rapid innovation in computer architecture. A computer that I used in my computer science degree was the Control Data CDC 6500, and I have a video where we visit the Living Computer Museum in Seattle, Washington, and hear card readers work and card punches. And if we ever get to the point where everything opens back up again, it's a tremendous visit to go see all the technology that really through the years, except that in the Living Computer Museum, they like to have everything running. And then you can take a look at a more modern, smaller, the Raspberry Pi, which the Raspberry Pi is actually not an Intel-based system. The Raspberry Pi is based on ARM, the processor that really became popular as a result.
Dr. Charles Severance is one of the world's most popular programming instructors. In this course,
AT&T sort of figured things out. Extremely popular thing. For a thing ever. The world was about to just adopt Unix. Unix was the greatest thing ever. Computer science departments were teaching Unix in their operating systems classes in the mid 80s. The problem became AT&T had never come up really with a business plan for what the purpose of Unix was, and so there was some fits and starts as to how they could monetize this extremely popular thing. And they didn't do a great job, and it took them a long time to figure out what was going to be successful. And by the time AT&T sort of figured things out, the market had moved on. And so Minix is an operating system that was developed in the Netherlands by Andrew Tannenbaum, and he built a completely free and open source operating system that was used for education. He built a textbook around it, and it was very popular. But he didn't want commercialization, at least not at that point in time. So he sort of held on to it too tightly. Again, kind of an intellectual property mistake. And in 1991, a program called Linus Torvalds decided he was going to build a fresh ground-up implementation of the Unix kernel that was 100% free. So he wasn't going to use Unix, he wasn't going to use Minix, he wanted to create another thing. And originally it was just like a hobby. I'm going to try to see how far I can go. By 1992, Linux started to work, and it adopted this license called the GPL, which is called the GNU Public Library License, which is a strongly open source license in the way that it's difficult to take Linux out of open source, which meant that people could then invest in Linux. And so Linux has become Unix, right? Linux in the modern world is the Unix-like system. And Unix tried to hold on for a while, but they really, really couldn't. And so the remaining Unix distributions are a tiny, tiny fraction of the marketplace, and Linux is the marketplace. So we can see some of this in some of the videos that I've got, like Andrew Tannenbaum will tell us the story of how Minix was created and how Minix kind of begat Linux, and so that there's some interesting stuff here, okay? So I'll lay on top of all this. Remember that 1978 is this moment in history where I claim like everything changed. Now, I've been a computer scientist for a very long time. I started in 1975. And in 1975, I learned things like Fortran on a computer, that CDC 6500 computer. It ran a special operating system called Scope Hustler. I knew how to do assembly. I knew to do Fortran and even Pascal. So Pascal in the 70s was one of these languages and I've got a video for Pascal as well, one of these languages that was sort of like saying, look, here's the future. Now Pascal was really aimed at teaching, and so I used Pascal in educational context. And as I became a professional programmer in the 1980s, I was using a bunch of stuff, assembly language, COBOL, a little bit of Unix and C here. It wasn't like by the early 80s, Unix was everywhere. At least not in the professional world, because the PC revolution was happening. So we had DOS, we had early Windows versions. I used things like DBase and Turbo Pascal. I taught classes of the IBM 360, and I taught assembly language. I used the DEC-VAX, and I used the VMS, not Unix operating system, and Fortran. And I also then taught in the mid-80s on an AT&T Western, I think it's called a GE AT&T 3B2. I taught Unix, I taught C, and I taught Fortran. And so even though we can trace back to like 1978 is the moment that everything changed, it's not like the market changed. The thing that happened in the 1990s, though, is that all these older computers, and the older computers vendors like Burroughs and Unisys and IBM and Cray and Control Data, as microprocessor speeds increased, all these little companies would create Unix workstations that were faster and faster and faster. And because they could build new hardware that was fast and then grab the Unix operating system and make their operating system work on their new hardware, it allowed for some amazing innovation. So I was using Sun, Ardent, Stellar. These are all gone now. IBM RS-6000, Convex C2400. I had a Next on my desk. I used C. But TCP/IP, Windows, HTTP, the web, and Windows and Mac OS were all kind of in the mix. But the innovation was really happening most rapidly in the Unix space. But by the 2000s, everything that I touched really had some aspect. I'm not a Windows person, so everything I touched had some aspect of Unix in it. Mac OS still has Unix in it, Linux, and my languages were sort of narrowing back down to Java, PHP, and JavaScript. And then in 2010s, right, Linux, Mac OS, Python, PHP, JavaScript. So things really have settled into a world, my own software development, where I'm pretty much using Unix-like systems all the time, and C-based or C-derived languages, because Python, Java, PHP, and JavaScript are all based on C. And that's why it's so important to understand C. I'm not writing C as a professional in any way, but I am using all my C knowledge every single day. And so that's a sort of a picture of me in my office. That's an IBM PS2 in my office. I was registering in 1989. I was registering with punch cards. When I first started, I was using a line printer and punch cards, and so there's my history. Now, I think it's important to acknowledge that, as I've shown you all these history documents and the videos and the oral histories that I've done, is there is a preponderance of old white males in here. And I think that it is important to talk a bit about that and why that is, perhaps. And so I would encourage you to take a look at an article. It's an NPR article. It's actually you can listen to it, about what happened to computer science. The title of the article is When Women Stopped Coding. Yeah, all the way up to 1980, computer science was just another field. And then it kept going up to sort of 1985, and then it went down. And so all these other fields have a pretty good gender mix, and the computer science does not have a gender mix. And so I would encourage you to listen to this article. Another area that you can learn something about the diversity in computer science is this book by Jane Margolis called Unlocking the Clubhouse. The essence of the book is really talking about how social pressure, advertising pressure in the early 80s made it seem as though computing was a guy thing. And in particular, it made it so that young men, even in high school, would go fiddle around with computers as a hobby. And by the time they got to college, they were pretty skilled. And if you weren't skilled, the college classes were designed for people who already knew what programming was. And if you were a woman and you hadn't played with computers in 1980 when you were like 14 years old, you came to college at a distinct disadvantage. And this is what led to this fall off, where colleges tended to teach to programmers who already knew how to program, and that really meant that the hobbyists, people who are in their youth before they went to college and played with programming as a hobby, had a tremendous advantage. Now, Jane did her work in the 80s, late 80s and 90s. I myself am older than that, and I think that to some degree this notion of the social pressure that said that computing was really for young men and not young women, it's actually as much a symptom as it is the cause everywhere. Impact on my URL operating system. I was my operating systems teacher. The interesting thing about 70 had a really large impact in my life. Her name is Helen Spence. She was a professor at Michigan State University, and I show you a URL to look at her oral history. So, I look forward to you taking the rest of this course. I look forward to you telling me if I'm right in my instinct about how important this is for you, especially after you take a few more classes and then find your way to being a professional.
That Bell Labs, bunch of smart people. call it 1,200 PhD level people in Murray Hill in basically one giant building. And so that's a lot of people rubbing up against each other, and they're all doing technical kinds of things. And the environment did not tell people what to do. It was go do your thing, and once a year, one side of one piece of paper, tell us what you did, and that will determine how much money you get next year. But it was a very long cycle. The one extra thing is that it was a problem-rich environment, and so there were things that you could work on, and there was this, I think, very gentle gravitational drift towards doing something that somebody else might care about. Now, lots of people, who cares what other people think? I'm going to do my stuff. But I think most people got some reward, psychic reward from, I do something, I give it to you, and you say, that was great. And then you say, and you tell me all the things that aren't yet great. But that kind of thing was very common at the labs because AT&T at that time basically supplied telephone service to most of the United States, 1 million people. All kinds of interesting problems in and around communications. And so no matter what you were interested in, there'd be some part of AT&T that could probably make use of that. So that was part of it. But then there was the external world as well. The research community, Bell Labs was just part of the academic research community. So they were both outlets, and the labs was perfectly happy to have people do either. And so all of that, I think, worked out really very well. And it helped to have stable funding. Because basically at that point, if you made a long-distance phone call in the United States, remember the concept of long distance, right? If you made one of those calls, a tiny slice of the revenue of that financed Bell Labs with the charter of make the service better. And we won't worry about the details of how you do that. So at the time, there was a lot of interest in programming languages. This all came out of the Multics experience, right? Where people at Bell Labs and, of course, the folks at MIT had realized that writing things in a high-level language made sense. And then the question is, what's the high-level language? And they started with PL1, which in the abstract sounded like a good idea, and in reality was a horrible idea because it was a horrible language. And so Martin Richards from Cambridge, University of Cambridge, had this language called BCPL, and he had spent, if I understand it correctly, a sabbatical year at MIT, planted the language in some sense. And it was much simpler, much cleaner, much better suited to system programming kinds of things than any version of PL1 would have been. And so the people at Bell Labs, Ken Thompson, Dennis Ritchie, and so on, had gotten some experience with high-level languages as suitable for writing lots of different things. BCPL wasn't a suitable thing for modern machines because it was typeless. And newer machines clearly were coming on stream that would have types like bytes and integers and maybe bigger things. And so at some point, Ken did a lot of experimenting. Ken Thompson did a lot of experimenting with simpler versions even of BCPL, a particular one called B, which was an interpreted language, no compiler. And that was, again, expressive enough that people started to like it. And that's sort of where I started in on this. I mean, I had written bits of PL1. It was awful. I'd written Fortran, better. But the B was sort of nicer to use, but it was still typeless and an interpreter as well, so it wouldn't be terribly efficient. But with the PDP-11 in the offing, and I don't remember the exact timing here, it was clear that a version of something that felt sort of like B, but which had some mechanism to include types so that you could talk about characters or integers, was going to be the way to go. And that's where Dennis picked up and started developing the C language and the compiler to go with it and so on. Portability was very much on people's minds at that time because although the core Unix work was done on the PDP-11, there were other machines at the time that were, in the same equivalence class. Interdata had a couple of 732, 832 numbers like that. And I think there were probably HP machines as well, and et cetera. And the other thing that was in some ways harder was that there was the big mainframe kind of computers that were used by the local computer center. And these were fundamentally stripped down versions of the Multics machines. They were GE 635 kind of things. And so those were big, clunky, word-oriented machines. They were, in effect, IBM 7094s cleaned up a bit. And getting something that would compile sensibly for those machines that really didn't have characters in a language which had become what it was, so it could manipulate characters. I think there was a bit of a strain there. But that portability, how do you get the same language to work on different computers? And Dennis's original compiler really was targeted at the PDP-11. And Steve Johnson came along with the portable C compiler, which basically separated the front end. Okay, let's recognize the language, let's build some intermediate structure, and then let's generate code for different kinds of machines. I had written a tutorial on B because, I thought it was interesting. Maybe I can tell other people how to use it. And so when C started to be used and I became somewhat better at using it, then I basically repurposed the B tutorial, brought it forward and made the C tutorial out of it. And so I used C for essentially all the software that I was writing at that time. And kind of liked it. It was good. It was a nice match for the way people think about computing, I think, but also a very nice match for the actual hardware of the time. You could imagine what the compiler was doing. All of it was clear, so efficient and expressive, and nicely matched to everything around it. And then somewhere in probably 1977, early-ish, I coerced Dennis into writing a book about it. First edition came out in '78, and at that point the language was pretty reasonable. The book, I think, it was right on the cusp of whether structures were fully part of the language or not. A bit of overhang there, and I don't remember, but I think probably they were not quite, but awful close. And since Dennis was doing both compiler and book, it was at least a consistent viewpoint. The question is, can you pick up a structure as a unit and pass it around, or do you have to do something special? So but that's a milestone. And then the next one is probably the 1988 book and the development of the ANSI C standard, the first standard, which is essentially, again, about the same time. And so I think those are the ways I measured. And at that point, call it 1988, give or take, just before you encountered it, C was probably just fine for anything you might reasonably want to do. And this is probably heresy or something, but I don't think that the changes in evolution since then have brought enough in some sense.
Welcome to C Programming for Everybody. My name is Charles Severance, and this is my reading of the 1978 C Programming book written by Brian Kernighan and Dennis Ritchie. At times, I add my own interpretation of the material from a historical perspective. Chapter 0, Introduction. C is a general-purpose programming language. It has been closely associated with the Unix system since it was developed on that system, and since Unix and its software are written in C. The language, however, is not tied to any one operating system or machine, and although it has been called a system programming language because it is useful for writing operating systems, it has been used equally well to write major numerical, text processing, and database programs. C is a relatively low-level language. This characterization is not pejorative. It simply means that C deals with the same sort of objects that most computers do, namely characters, numbers, and addresses. These may be combined and moved about with the usual arithmetic and logical operators implemented by actual machines. C provides no operations to deal directly with composite objects such as character strings, sets, lists, or arrays considered as a whole. From earlier chapters. Since C is an evolving language that exists in the current of such in general majority in the major recording of Chapter 0 of the 1978 C programming book written by Brian Kernighan and Dennis Ritchie is part of my C Programming for Everybody course, where I teach C from a historical perspective. My name is Charles Severance, and I'm the teacher of the course. Hello, and welcome to C Programming for Everybody. I'm Charles Severance, and I'm your professor for this course. In this lecture, we are going to do a very rapid translation from Python to C. So as I've shown you in our earlier lectures, C is kind of like the mother tongue of advanced programming languages. Python itself was written and still is written in C, and Python is deeply influenced by C, even though the syntax looks very different, right? And if you've taken all my other other classes, you will have seen PHP, you'll have seen JavaScript, and to some degree even CSS takes some of its inspiration from the syntax of C. And so I'm not intending for this to be your first programming class. I intend for you to be an expert in Python. Well, not expert, but certainly I'm not going to tell you what an if statement is. I'm not going to tell you what a variable is. I'm going to just tell you how to use variables in C, and I'm going to tell you how to use if statements in C. And so that's why a solid foundation of Python, not wizard, but solid foundation of Python is essential. And frankly,